Hi everyone, we are Team Titans. Today our presentation will revolve around the game called The Control of the Cell Cycle, its game design and learning objectives, theoretical analysis of its educational potential, its effectiveness in a real-world learning context, and our suggestion towards game improvement to better achieve its learning objectives. So, what is The Control of the Cell Cycle? The game was published in February of 2002 and is classified as an educational game because it can be used in a formal education setting and a simulation game since it recreates the real-life process of cell cycle regulation. The discovery of cell cycle regulation in 2001 is the inspiration behind the game's development. The game's learning objectives are first, to recognize the events occurring during mitosis and what happens in our body when cell dies. Secondly, to learn how the human body knows when to make new cells. Third, to identify different phases of mitosis, order of cell division, and what happens to prevent the mistake during the process. And lastly, is to understand the way cancer cells are formed. To play the game, the player will act as a cell division supervisor, or also known as CDK in cycling, and its role is to ensure that the phases associated with cell cycle regulation are in proper order. To achieve this, the game requires the player to undergo a brief lesson about human cell division and multiplication, cell division frequency in different body organs, events that take place during cell death, and the cell cycle division. After the brief lesson, the main part of the game commences, and the cell cycle division supervisor will be directed to the cell cycle control system. This is where they must make sure that processes of cell cycle regulation are in correct order. And when the division supervisor clears the main stage of the game, it will be directed to the final stage, which is a short discussion about the cell cycle regulation, CDK cycline's role, and cancer cell formation. Next, we will discuss the game elements that can be found in the control of the cell cycle game's design. First is the game mechanics. The mechanics of the game are first is not to mess up the first phase in the process of the cell cycle regulation 3 times in a row, or else the game is over. In other words, the player has to start all over again. Secondly, if you pick a wrong phase during the second until the last phase of the process, the system will automatically give you 10 seconds to correct your mistake, or else the energy in the storage will run out. And if it runs out, you will be thrown back outside the cell cycle control system, and this time, the main part of the game has to start all over again. The next game element is the feedback. Feedback can be observed when the player selects the wrong phase for the first time. They will receive it after being thrown back outside the cell cycle control system, informing them about the choice they made and how many cells are now dead and their chances to play the main game again. The third element of the game is the aesthetics, which is the game's visual elements such as images, animation, color palette. Let us now discuss the theoretical analysis of the game's educational potential. One of the notable theoretical underpinnings of the control of the cell cycle is the cognitivism. The theory argues that learning involves thinking other than simulation and reinforcement. Moreover, it highlights mental processing in learning. This can be observed when the game requires its player to undergo brief lessons related to the cell cycle regulation before playing the main part of the game. Another theory that is apparent is the elaboration theory, which posits that learning shall be organized from basic to complex, which is evident in the manner that game presents information to its player, from basic information or knowledge about human cells to complex topics such as cancer cell formation.
Next is behaviorism. The game begins by displaying the cell cycle with a short explanation for each phase. After reading and analyzing the information, the player can start choosing the correct response to advance in game. Once the player picks the wrong answer, the game will restart at the first level or situation, and it will continuously happen until the player learns and chooses all the correct answers. The part of the game where there is information about the cell cycle, feedback after choosing the correct or wrong answer, and forcing players to restart the game if they choose wrong answer entails that the game reinforces correct answers. The punishment, forcing players to restart, in the game is part of behaviorism. As Wu et al. 2011 explained that reward punishment and feedback aid in changing behaviors. The next is cognitive load theory, which will be discussed in evaluation by Kyla.
Let's talk about how the game design promotes learning. First, the game's development is inspired by a discovery in the field of physiology, which is the cell cycle regulation. Secondly, the game is designed to deliver learning about cell cycle regulation, which is apparent in 3 different parts or stages of the game. How about the game's learning objectives? Well, its learning objectives are supported through first by imparting knowledge about cells' nature, cells division frequency, cells death, and cell division itself in the initial stage of the game discussion. Then, playing the game or the main part of the game through selecting the process of the cell cycle regulation in order. And lastly is discussion of the cancer cell formation at the final stage of the game. The game is designed through integrating all the information about cell cycle regulation.
Moving on to evaluation. So in this part, we'll tackle the strengths and weaknesses of the game in its real-life application and in achieving its educational goals. Our chosen game control of the cell cycle has various essential components that enhance its quality, which are integral to achieving the game's educational goals. First of all, the most remarkable component of the game is its simplistic yet engaging structure. Players are introduced to creative visual elements and concise written information that provide relevant details about the cell cycle, keeping them engaged as it's not text heavy. And animation is also used. This combination of text and visual elements reflects the concept of multimedia effect, which posits that people learn better with combined text and visuals instead of using a text or a visual alone. Secondly, the game is presented in an easy-to-digest format. It doesn't involve distracting elements, incorporating the principles of cognitive load theory. Considering that abstract concepts such as the cell cycle require more complex information processing, it's crucial to avoid unnecessary stimuli that might increase the learner's extraneous load. By including only the vital components, players will stay focused while not feeling intimidated by the general complexity of the subject matter, due to the game's organized and straightforward approach. Another positive element of the game is its real-time feedback system. As we have learned, feedback is one of the four crucial traits of the game. This game monitors this idea by providing immediate outcomes with every decision a player makes, helping them self-reflect and review the presented information on the screen. Moreover, the game harnesses lower and higher cognitive levels, specifically the player's ability to remember, understand, and analyze. There's a feature that forces a player to repeat the game if they choose multiple incorrect answers. With this in mind, the game pushes them to recall basic facts, understand the presented information, and carefully analyze the provided details in order to accomplish the game, encouraging them to strengthen their critical thinking and memorization skills. While the game has advantages in achieving educational goals, several factors may affect its effectiveness in a real-life learning context. The game being in 2D renders it limited in some aspects. There's an evident lack of interactive features found in 3D games or simulations. The absence of achievement and social components in this game may not apply well in a physical learning setup due to the lack of competitive and social activity. The lack of reward system and a venue for collaboration may cause a decrease in motivation and social connection. While the simplicity of the game benefits the beginners or those with basic knowledge about the cell cycle, the content, due to its 2D structure, may oversimplify the subject matter. For learners who want to learn about the complexity of cell biology, this game may not satisfy them due to a lack of in-depth learning experience. Conversely, those without prior knowledge about the cell cycle may not be able to follow through the stages of the game, making it not suitable for all learners with varying preferences and academic levels. Furthermore, since the game is delivered in 2D, it heavily relies on text and visuals, which might make it insufficient for real-life application, as the complexity of cell biology requires hands-on learning experience for learners to grasp the concepts. Educational games like these may become more effective when delivered through 3D simulations, as they offer higher interactive components. Otherwise, additional learning activities and resources are necessary to supplement the learning processes of students, such as practical laboratory activities and watching educational videos on the processes of cell cycle.
Now, let's discuss how the control of the cell cycle design enhances the learning experience of the target audience. First, it makes learning fun and engaging. The aesthetics are what makes it interesting. CAP 2012 states how these elements convey information regarding the game and the topic. For instance, the environment of the game is in the cell cycle control system center, where there are monitors. This information or design tells us that the character or the person playing is a real supervisor that controls and monitors the cell cycle, which immerses us in the game. Meanwhile, the immediate feedback in the game corrects players' misconceptions regarding the topic. Next, it enhances information retention and helps in understanding complex ideas. The use of multimedia aids in processing information and avoiding cognitive overload. With text and its visual representation, it builds a better connection between those pieces of information, leading to better retention and understanding of complex ideas. The conversational style of the game is said to help improve individuals' generative processing, which is concerned with generating new knowledge based on prior knowledge. Problem solving and critical thinking skills to develop when playing control of the cell cycle. The image and the text describing the situation allow players to analyze and recall prior knowledge regarding the cell cycle. In addition, players who are struggling to advance in the game could help strengthen their problem solving skills by identifying the issue and finding their way to move forward. Now, here are suggestions for improving the game to better achieve its learning objectives. First is to improve feedback and coaching. Mayor and me conducted an experiment using coaching aids in games, resulting in a positive learning outcome. Thus, to improve the game, it needs to include an explanation for why choosing this phase is wrong instead of just saying the answer is incorrect to inform and scaffold the player to complete the task. In this way, players comprehend the importance of each phase being in sequence and better distinguish them. Next is to add facial expressions or any emotional elements that will improve effective factors in the game design. Mayor Andy states that including some emotional design elements and making players feel good increases engagement and facilitates learning. Next is to include an incentive system, timer, and competition in the game since they increase the motivation of players, especially those achiever type players. Next is adding social factors to the game design. Adding a multiplayer option could increase the motivation and performance of players regarding the topic. Mayor Envy, collaboration among the other players or learners could be done by distributing tasks while also allowing them to watch the other players doing different challenges like doing checkpoints. These checkpoints should involve players in checking the cells and not merely selecting what part of the cell should be checked in the checkpoint. Also, we can add game levels by promoting the supervisor to a higher position with more difficult tasks, which tackles in-depth information about the cell cycle.
That's awfully.